Jennifer McKay. I am Policy Specialist at Tip of the Mitt Watershed Council. The Watershed Council is very happy to host tonight's event, the Northern Michigan Pipeline Symposium. Since 1979, the Watershed Council has been the lead voice on behalf of Northern Michigan's waters. We work to protect and restore the lakes, streams, wetlands, and groundwater for now and future generations. Part of that role includes hosting educational events such as this one to ensure we're all informed on topics that impact our waters. One of the potential risks to our inland lakes, streams, and Great Lakes is the network of oil and gas pipelines buried beneath our feet. One pipeline in particular has drawn significant attention. Line 5, owned and operated by Enbridge Energy Partners, is a hazardous liquid pipeline that carries crude oil and natural gas liquids. This is the only crude oil pipeline in the Watershed Council service area, but it is not the only one in northern Michigan. This particular pipeline happens to traverse through the Straits of Mackinac, but not only that, it also goes under the Indian, Pigeon, and Little Sturgeon rivers, passes in close proximity to many of our sparkling inland lakes, and goes through about 10 miles of wetland habitat. The wealth of natural resources we have here in northern Michigan make us uniquely vulnerable. A pipeline failure in this region would not only be significant to the health of residents and visitors, but also to the water resources themselves and the tourism industry it provides. We all know our quality of life is linked to the health of our waters, and our economic well-being is linked to the health of those waters. Therefore, it's in all of our interests to help protect our northern Michigan water resources from the devastating impacts of a pipeline failure. So here we are tonight. Our goal is to bring greater attention to pipelines and the way the community can work collaboratively to reduce potential risks and impacts of pipeline failures. This is critical to the future protection of northern Michigan water resources and aquatic species, as well as local communities that depend upon the high water quality for their way of life. In light of that, thank you again for all coming tonight to learn and stay informed. I'd also like to thank all of the agencies and organizations whose participation made tonight's event possible. We're very fortunate to have with us this evening an impressive array of representatives from various agencies and entities directly involved in the operation, safety, emergency management, and spill cleanup for pipelines in northern Michigan. Hopefully you all had a chance to interact with them during the last hour. While they all work in some capacity on pipelines, they are all here independently. They may have different perspectives or opinions based upon their respective roles and interests. So quickly, I'm going to review the format for this evening. We'll begin with 2 short presentations regarding pipeline safety in Line 5. Alan Beshore from the Department of Transportation, Pipeline, and Hazardous Materials Safety Administration will provide information about federal regulations designed to ensure pipeline safety. Then Brad Shamla from Enbridge will provide information on Enbridge operations here in northern Michigan, as well as Line 5. And we'll close with a short overview of oil spill response and planning from Ralph Dahlhaus with the United States Environmental Protection Agency. After these short presentations, we'll engage in a panel question and answer section based on the pre-submitted questions from you in the audience. The questions will be directed to an individual panel member with 2 minutes for a response. We will then allow 1 minute for additional comments from other panel members. During this period, if the responses raise other questions for you in the audience, we will pass out cards that you can write down those additional questions. And then staff from the Watershed Council will collect them at the end of the event. We will try our best to then get answers to those of you that submitted questions. The audience members tonight will not have the opportunity to directly address the panel members with questions or comments. And please be aware that due to time constraints, we won't have time to get to the written questions this evening. That's why we will try to get follow-up responses to you. We've chosen this format in order to facilitate responses to as many questions as possible this evening during the allotted time. Again, our objective here is to disseminate information about pipeline operation and safety, and simply due to the volume of questions received and the time constraints, we'll only pose those questions directly related to the water resources in northern Michigan. We know this topic is of significant interest to the entire community, and we appreciate your cooperation in helping maintain a respectful atmosphere this evening. So in that vein, I will be asking that you refrain from clapping, cheering, booing, and other activities that would reduce the amount of time we have to address the important substance of this symposium. So with that, I'm going to introduce our first presenter, Mr. Alan Beshore from the Pipeline and Hazardous Materials Safety Administration. Alan Beshore has been a senior engineer with the Central Region for over 10 years. Alan has been involved in a variety of accident investigation, inspection, compliance, and pipeline integrity assurance activities. His primary focus has been on gas integrity programs and corrosion control. Alan transferred into the role of a community assistance and technical service manager in 2011, and now enjoys interacting with a broad variety of pipeline safety stakeholders. Prior to joining the Pipeline and Hazardous Materials Safety Administration, Alan was an investigator with the National Transportation Safety Board, a manager and engineer for natural gas transmission pipeline operators, and an inspector with the Missouri Public Service Commission. Alan has BS and MS degrees in chemical engineering from the Missouri University of Science and Technology, and is a registered professional engineer in the state of Missouri.
Thank you, Jennifer. And thank you all for coming tonight. So, as Jennifer mentioned, I'm with the Pipeline and Hazardous Materials Safety Administration. I'm going to have to figure out how to do there we go. I'm out of the Kansas City office. The Central Region handles this area. So there's my contact information. If you, they're going to post the slides afterwards, so if anybody has any follow-up questions, feel free to contact me. I just want to talk, I got a few slides on just the role of our agency. Our agency does both pipeline safety and hazardous materials safety. I'm going to talk about pipeline safety because that's the office that I'm in. So we regulate about 2.6 million miles of pipelines that support various aspects of the industry, electric generation, transportation systems, those kinds of things. The last comment there, interdependencies between pipelines and other services are not well understood because the economy is very, very complicated. So feeding one industry, that industry feeds another industry. So the direct role of pipeline transportation is a little bit unclear. Our mission at the agency is to protect people and the environment from the risks of transporting hazardous materials by pipeline. So what do we regulate? There's about 185,000 miles in the country of hazardous liquids pipelines operated by 400 plus entities. Over 300,000 miles of gas transmission pipelines with 950 some operators. And then gas gathering, and the bulk of it is gas distribution, which we issue regulations for that. But most of the enforcement activities and the inspection activities are done at the state level for all of the distribution systems in the country. So if you have natural gas distribution in your neighborhood, it's inspected and regulated by the Public Service Commission here in Michigan. So there's a picture of the pipeline system. That's the red is hazardous liquids. The blue is natural gas transmission pipelines. So as you can see, historically there was a lot of energy production in Kansas, Oklahoma, Texas areas. So there's a lot of pipelines that originate in that part of the country and transport material then out to this area and others. So approximately 185,000 miles of hazardous liquids pipelines. 70% of that involves interstate commerce. I'll talk about alternate modes of transportation here in a minute that present different and higher risks. 93% of the U.S. transportation is fueled by oil. It accounts for 17% of the total freight in the transport in the United States at 2% of the total freight bill. So it's a very efficient process. By comparison, for hazardous liquids, there are alternatives. A truck can hold about 9,000 gallons of oil or refined products. That's a pretty big truck. Most of them are a little smaller. Barrels is the term we use more often. Rail cars about 33,000 gallons. So if this topic of discussion tonight is primarily Line 5, as Jennifer mentioned, it's not the only pipeline in the area, but the capacity of Line 5 is published at 540,000 barrels per day, which equates to approximately close to 700 rail cars or over 2,500 tanker trucks. So to put into perspective the amount of product that is transported through the pipeline, those are numbers to kind of keep in mind. So if you look at the whole system over a 5-year window, this is the total amount of products transported by pipeline. So a barrel mile is taking a barrel of oil and moving it a mile. So it's a unit of measure that's used to compare different modes of transportation between trucks or rail or whatever. Oops, that back there. So there were over 9 trillion barrel miles of crude oil transported in this 5-year window that I'm looking at, which equates to 11.8 billion miles by rail car or 43 billion tanker truck miles. So that's just the crude oil transported in 5 years. And also, this is refined products, and this is also highly volatile liquids, HVOs. Can you hear me when I try and read my slides? Because I hear a difference. But I have to look at the slides or I don't know what I'm saying. Anyway, the numbers are kind of staggering because you've got close to 20 trillion barrel miles of various products that are being transported in that 5-year window. And so that slide, there's the alternatives at this point in time. We don't have the infrastructure to handle those other methods. And historically, rail didn't account for more than like 2 or 3% of the transportation. And you see a lot of news now that rail is being used a lot more often to ship crude oil, and it's got some issues, and we're seeing some of those issues. But historically, it hasn't transported a whole lot of the product. And trucking was really only used to take the gasoline from the terminal to your local gas station. That's the extent of what trucks have been used for in the past for the most part for transportation. The pipelines account for about 70%. And then the second largest mode of transportation for the oil and refined products is by barge. Maritime transportation was over 20%. I don't talk about that much because they don't do that much around this part of the country. So natural gas pipelines are a little different. About 25% of the energy consumed in the U.S. is transported as natural gas transported by pipeline. Approximately 7 million residential and commercial customers. There's significant growth underway in that business. Not many alternatives. This fella here in China has to go up and fill up his bag of gas, and that lasts 3 to 5 days for the family's heating and cooking needs. So fortunately, it can work convenient. It comes to our house. So, but there aren't a lot of alternatives for natural gas. This topic of this forum is really not related to natural gas so much, but there is some work being done on railroads. They're looking at some locomotives that are powered by liquefied natural gas, where they can carry a natural gas tanker or two behind the engine and that kind of thing. But it's moved intercontinentally across the oceans. But to move it around the U.S., it's primarily 100% by pipeline. So here in Michigan, we have some transmission pipeline mileage. These numbers are on our website. There's a little over 500 miles of pipeline for highly volatile liquids is what that HVL stands for. That's propane, ethane, other products that evaporate very quickly and generally gaseous at ambient temperature. We're a little over 1,268 miles of crude oil pipeline, 1,400 plus miles of refined products, and 8,700 miles of natural gas transmission lines. So that's what's here in your state. And these numbers are on our website. You can look that information up if you're familiar. I'll have a link or a slide show on our website here in a minute. So where are we? I'm out of Kansas City. If you look, this is our central region. So we have 12 states, including Michigan, that are out of our Kansas City office. We have inspectors, 2 or 3 inspectors that live and work out of their homes outside the Kansas City office, but the bulk of us are there in the region office. We also have region offices in Houston, Atlanta, Denver, and Trenton, New Jersey. And our headquarters is in Washington, D.C. So we have base programs that we do as an agency. We analyze and trend data. We develop regulations, and we then inspect, enforce those regulations. We have a role with the emergency response in terms of reviewing spill plans that I'll talk about in a minute. We have integrity management programs. Our primary focus as an agency is keeping the product in the pipeline. So our focus is on that and less on emergency response. I'll talk about that a little bit more because other agencies have a far bigger role. We administer pipeline safety grants. I mentioned that, like in Michigan, that the Public Service Commission inspects and regulates the natural gas distribution systems in Michigan, and we, at the federal level, we have a program that pays for portions of that cost. And then we've issued, so we're highly involved in damage prevention, and we've got some fairly new regulations on public education requirements. We have a department, we do some research and development. We don't actually do the research and development, but we fund some research and development projects. So our strategic focus is safety, reduce the risk of harm to people due to the transportation of hazardous materials by pipeline. Reduce congestion. The pipeline system capacity loses capacity due to corrective action orders. Due to incidents. We issue corrective action orders and things like as a result of that. We're standardizing. We work in our region, we work a lot with the Canadian government because they have a counterpart. And for example, Enbridge operates in both countries. And so we do coordinate efforts with the Canadian government as well as the Mexican government, although their pipelines we don't in the central region interact much with the Mexican government. Environmentally, we want to reduce the risk to the environment due to the transportation of hazardous liquids by pipeline. And then, as I mentioned, mitigate the consequences of a failure as part of our preparedness and response effort. So, in years past, we did our inspection program, and we would say, okay, we're going to go do inspections every 2 or 3 years, and that's kind of how we do things. And we're trying to move forward to where we're focusing our efforts on improving our data, improving our ability to analyze data so we can focus on risks. So we want to focus on pipeline companies that need our attention. We want to focus on pipeline systems that present a higher risk. So that's where we're spending our resources. So we're trying to kind of redesign our inspection processes so we're not so much hung up on doing an inspection every 2 years, just whether they need it or not. But we want to spend our time with the people that need our attention. And so we've got a lot of efforts underway that are kind of talked about on this slide. The inspection integration process, I'll mention that in years past we would come and do an inspection and look at operations and maintenance procedures, or look at integrity management, or look at some specific aspect of a company's operations. We still do those specialized focus inspections, but we're trying to get away from that stovepipe process to where we go in and do an inspection and then try and focus in our attention on weaknesses in the program to where we can and try and improve those things. I think I backed up again. Sorry about that. Okay, so just to kind of briefly touch on over the past years, the trend in serious accidents has been reducing. Serious accidents are defined as accidents where there was a fatality or some number of injuries. It's a subset of the reportable incidents. Unfortunately, we've seen an uptick here in the last couple of years on the hazardous liquid accident side. We're not real sure, why or what we maybe need to do differently to reverse that, or whether it's actually a trend or just a blip in the data. But the numbers have not been so good the last couple of years in that program. Some of the causes of accidents, the highest causes are corrosion, equipment failure. Excavation damage is one that we've focused a lot of attention on, and we've reduced those numbers. May not be on the right line. Let's see. Yeah, this green one here. So we've done some good there and reduced those numbers. You'll see excavation damage is a big high. This is the hazardous liquids pipelines only, transmission lines. So those are primarily located in rural areas, and there are some that are in urban areas and stuff, but for the most part, they're located out in more rural areas. So most of the excavation damage is a big issue is on the natural gas distribution systems that are in your neighborhoods where there's a lot of construction and excavation activity going on. So the numbers are a lot higher if you look at the causes for excavation damage, for example, in distribution systems, which is why we focus a lot of attention on it. These other items we address during our typical inspections, we always look at their corrosion programs and things like that to try and get a handle on those processes. So here in Michigan, we'll go back to Michigan. On a 3-year average, all pipeline systems, that includes the natural gas distribution and everything, there's an average the last 3 years from 2010 to 2012, no, 2011 to 2013, 7 significant incidents, 1 serious incident with 1 fatality, and that's an annual average. For the hazardous liquids pipelines, there were 2 significant incidents on average each year, an average of almost 800 barrels lost. We also have a number for the barrels spilled, but they recover a certain amount of that or some portion of that, so they'd also report the amount that was lost net. But in those hazardous liquids, there were no fatalities or injuries in that 3-year period here in Michigan. So, 811, we always, support the effort here to call before you dig to prevent the excavation damage. What we don't do, I'll talk about a little bit, because we get a lot of inquiries from people that don't understand specifically what our role is. We don't authorize or approve pipelines. Our agency doesn't decide what product needs to be transported by pipeline from point A to point B. The Department of Transportation, the entity decides somebody has this product somewhere and they need to transport it. And our role is to make sure that can be transported safely. We don't oversee pipeline siting or routing, so you see a lot of discussion about new pipelines. The next item here, eminent domain, people get their property condemned for a new pipeline to cross it. We don't give them that authority. We don't have anything to do with that process. We don't monitor or track commodity shipments. We look at what products are in the pipeline because we have to look at the threats to the pipeline. So we understand what products are being transported, whether they're corrosive, those kinds of things, whether internal corrosion is a threat to the integrity of the pipeline. But we don't monitor what's in the pipeline at any given time. Most pipelines operate in batch form, so a refined products pipeline, for example, there'll be a batch of gasoline going through it, and then they'll switch and they'll start putting diesel fuel through it. They might even put highly volatile liquids, propane or ethane through it, and they're put in batches, and so they don't report to us or whatever what product is in the pipeline at any specific given time. We don't enforce right-of-way contract provisions or resolve disputes. So if you have a pipeline located on your property, they come out and they do some work or they do some excavation and they don't restore it back to the condition it was in. Unfortunately, we don't have any authority to correct that or to work that out. And we don't do long-term environmental remediation. There's a lot of people from the state environmental agencies here, or the EPA, and the environmental agencies are the ones that are administering those processes to do the long-term remediation, if there is a spill. So what do we do? Well, we have regulations. We have two primary parts that apply to hazardous liquids pipelines. Part 195 is the transportation of hazardous liquids by pipeline, and that's the bulk of our regulatory requirements for liquid lines are in that part. We have another set of regulations for natural gas. They're separate. I'm not going to talk about those. And then Part 194 applies to response plans for onshore oil pipelines. So how do we spend our time? Well, we spend about 50% of our time doing inspections. We do failure investigations. The stakeholder outreach is what I'm charging this time to today. Construction oversight is also inspections. This teamwork, don't confuse that for team building. You know, we're not catching each other as we fall backwards or playing paintball. But we have teams that, for example, I'm the chair of the gas integrity management team. So we have representatives from each of our region offices that meet and talk about, you know, changes to our program for gas integrity management, whether we need to update our question sets based on enforcement cases, what we need to focus on, what guidance we need to provide our inspectors. It's important for us to have some consistency between our regions on how we're approaching things, and so that's what that teamwork number is. And then we have a significant component of our time doing training. We currently have openings in Kansas City. If any of you want to go to USA Jobs and take a look. But we have had some reductions in force in the last couple of years where we had an early out retirement program. So we're getting a lot of new people into our office that we do spend a lot of time trying to train them. And so that's a pretty significant part of our time. So to talk a little bit about what is in Part 195, first of all, what's a hazardous liquids? So that part applies to these hazardous liquids, including refined petroleum products, gasoline, diesel, jet, natural gas condensate, crude oil, highly volatile liquids, ethane, propane. A couple you may not really be familiar with, anhydrous ammonia. There are a couple of pipelines that transport anhydrous ammonia. Not up here, but in the Midwest, there's a couple of pipelines. Carbon dioxide, there's some more pipelines being proposed for putting that carbon dioxide underground, getting rid of it. They're using it to enhance some recovery where they inject carbon dioxide to help produce new oil. And ethanol was a big thing, and we thought there'd be some pipelines coming around that were batching ethanol. That's kind of died down. There's some specific things that need to be aware of if you're going to build an ethanol pipeline. But we haven't had anybody, at least in our region that I'm aware of, that's actually built a line dedicated just to ethanol. So some of the things we have in our regulatory requirements, there's reporting requirements. If somebody does have a release on the hazardous liquid side, if it's over five gallons, they have to call and report it to a National Response Center, which is a number manned by the Coast Guard 24 hours a day. They also have to submit annual reports where they talk about the mileage they have in service, different commodities that they've transported. There's a lot of information in there on they report by decade, the year of installation on some of the pipes. They report by diameter, the different pipe sizes. There's some other specific things that they need to report on their annual reports. We have regulations that cover the design, the material selection, the construction process for new pipelines. So that we have regulatory requirements for that. For the pressure testing that they have to do upon completion of that construction, or if they want to revise their operating pressures later on, or for whatever, we have regulations on that. Our maximum operating pressure that they can establish is laid out in our regulatory requirements. We have requirements for maintaining their facilities. They have to inspect valves. They have to lots of different aspects of maintenance. They have to do patrolling. So if you have a property that has a pipeline on it, they'll fly it every 2 or 3 weeks. Those kinds of things are covered in our maintenance requirements, how they can do repairs, some things like that. Requirements for managing corrosion and controlling corrosion so that they don't have integrity issues. Integrity management regulations, they have to do assessments periodically to assess the condition of their pipe. And then they have to take actions if they find issues. We have regulations covering how they have to qualify and train their employees to be able to do specific tasks that are safety related. We have public awareness requirements. One of the requirements is that they are required to establish and maintain liaison with emergency responders. And so we've looked at that for many years in our inspections to make sure that they're talking to the local responders and providing information on what they're transporting in the pipeline so that the communities can be prepared. And on damage prevention, as I mentioned, the 811 number. So as part of our routine process, the topic of discussion here tonight is Enbridge's Line 5, and you're probably aware they've had a recent project to increase the capacity of Line 5. So as part of that, they had to submit a notification to us. It's in our requirements that certain projects of a certain size or they involve a certain number of miles of pipeline construction need to be notified. So they provided us that notification in May of 2012. We met with them and got a briefing on what the project entailed. We performed a special inspection then upon completion of the project where we reviewed their hydrostatic testing records and things like that from the project. So, we were well aware of these projects that are going on and involved in the oversight of them. So we're talking specifically about the Straits of Mackinac. As part of our inspection process, they're required to inspect pipelines under commercial waterways periodically. We review those inspections. There was some mitigation activity. We reviewed that activity. We've reviewed the original construction records and things from when the crossings were installed. So we've taken a look at a lot of that information. And the integrity assessments that are done periodically is part of what we do on all our inspections. We review the integrity assessments to make sure that they're finding and fixing integrity threats that they need to address. So I'll refer, if you're interested, to there was an April, I have 25th, I was thinking it was the 29th, but anyway, that may be a typo. But in April of 2014, we responded to your senators had inquired about some specific information on Enbridge's Line 5, and so that letter's, you can review that if you're interested. It goes into it has some detail on when they did integrity assessments on specific pipelines at the crossings and things. It doesn't get into detail other than when those were done. So Part 194 I'll touch on, about out of time here. So oil is a little different in Part 194. It's not the same as hazardous liquids. Now we're talking about oil. So natural gas isn't covered. Anything that volatilizes or is a vapor or atmospheric under ambient conditions is not included. So propane, ethane, they're not included in what's oil. Oops, I'm on that slide. Anhydrous ammonia is not petroleum, so it's not covered. Carbon dioxide and ethanol is the same way. So there's a little different definition of what's covered under Part 194 than what was covered under Part 195. So their facility response plans are outlined in the Part 194, what they have to have in those plans. The plans are submitted to us for review and approval. Those plans need to be resubmitted every 5 years or if there's a significant change in information. So again, the Enbridge Line 5 plan of interest to you all here is their Superior Region Response Zone Plan, which was submitted and reviewed and approved by our office. And the public version is posted if you go to our website, you go to the FOIA electronic reading room, you can review that plan. There are portions of it that are redacted. We have the obligation under the latest act that was signed in 2011 to consider restricting back information on the worst case discharge and where that's at and how it's calculated and things like that for security sensitive type information. And so you'll see that being redacted out of those plans. But the only other thing is personal phone numbers and stuff like that we have to take out. So what is our role in the event of an emergency? We're not an emergency response agency. We're not going to be conducting environmental monitoring. There's a lot of environmental responders, and hopefully you talked to some of them earlier before the meeting, that do these activities, that direct remediation. But we have people that are pretty knowledgeable about pipelines and pipeline activities and pipeline maintenance and things like that can be of value to the incident command system during the incident if disagreements arise and they need to ask us a little bit about pipeline-specific questions. And then, so what do? We investigate the cause of the release, and then we make efforts to verify the future integrity of the pipeline. We monitor repairs. We may require a reduction in operating pressure. We may require them to have a written restart plan, things like that before they start back up. We might issue a corrective action order that requires ongoing activities to do other additional inspections or make additional repairs, that kind of thing. That varies on a case-by-case basis based on what's happening with the accident. And then we apply those findings to either, we may find something that's applicable to an entire pipeline system that we need to address with that particular company-wide throughout their whole pipeline system, or it may be something that we need to consider rulemakings and things like that to apply those findings to the industry as a whole. So there's my contact information. My colleague Harold is also in the Kansas City office. Feel free to contact either of us if you have questions down the road. Thank you.
Thank you, Alan. Now you hear from Mr. Brad Schauma, Vice President for Enbridge U.S. Operations, about Line 5. Brad Schauma has been with Enbridge for more than 2 decades, working in operations, engineering, business development, and administration across Canada and the U.S. He is currently Vice President, U.S. Operations, where he's responsible for the U.S. liquid pipelines operations and gathering systems. Since he started with Enbridge in 1991, Brad has taken on roles of increasing responsibility within the organization, including leadership positions in business development, Canadian operations, the control center, gathering systems, U.S. engineering, and U.S. operations group. In his most recent role as Vice President Market Development, Brad was responsible for leading the business development activities related to the Enbridge Mainline, new market access, contract terminals, and strategic acquisitions and divestitures for liquid pipelines. Prior to joining the Business Development Group in 2008, Brad served as General Manager in the Liquid Pipelines Operation Group, overseeing mainline operations in Saskatchewan and Manitoba, as well as the company's first wind farm near Gull Lake, Saskatchewan.
Thank you, Jennifer and Renetta and all of the tip of the mitt representatives here tonight. We really do appreciate the opportunity to be here tonight, and to all of you who have come out tonight to listen and participate in tonight's event. We really do think there is great value in getting out and having these kinds of discussions, and to hear exactly what it is that the pipeline is and what it's not, some of the regulations, and some of the concerns that you all have, and how we're going to address those concerns. Because I think at the end of the day, operational reliability and safety is important to everybody in this room. And it's certainly a cornerstone for us as we conduct our business on our system. So I wanted to start by just giving a brief overview of Enbridge and our overall system. We do operate the world's longest pipeline system in Canada and the U.S. The system you see across the map on the page, it's about 50,000 miles of pipelines in collective between our gathering systems, main lines, and others across North America. Movements through our system account for about 15% of all total U.S. petroleum imports through the Enbridge system. We deliver about 2.5 million barrels per day of crude oil and liquids petroleum through our system. And just as a point of reference, that accounts for about 50%, and actually more than 50% of the crude that is provided to the Great Lakes refineries in Chicago, Detroit, and Superior, Wisconsin. We also are a player in the gas pipeline gathering and processing system. We own about 1,000 miles of offshore pipe and onshore gathering pipe as well, but about 1,000 miles of offshore pipe in the U.S. Gulf of Mexico. And we gather and move about half or 50% of the offshore gas production in the Gulf. On the Canadian side of the system, in Eastern Canada, we own and operate the largest natural gas distribution system in the Toronto and Ontario areas. We also, as an energy company, have an emerging green energy platform. We currently have ownership interest in about 1,800 megawatts of wind, solar, geothermal, and heat waste recovery through our system, for a total capital investment of about $3.5 billion in green energy technologies. On the growth side, we've got a number of growth projects underway. I won't get into detail on those today, but they total about $35 million in committed growth and expansion projects. We've made a commitment to a neutral footprint in our development, and it really stems from our former CEO, and it's something that we've really committed to, and that's basically we want to produce a kilowatt of power for every kilowatt of power we consume on the pipeline right away. We want to provide an acre of land for any acre that we use in our projects, and we also want to plant a tree for every tree that we have to remove as part of our operation. And that neutral footprint, I don't have a scorecard to go over tonight, but it is something that we are committed to. And then finally, we're an employer, and we employ currently about 11,000 employees and contractors across our system. That's up from about 6,500 just a few years ago in 2011. So some significant growth happening, but also some significant areas of focus that we're going to talk about here tonight. And 250 of those employees and contractors are here in Michigan. Looking at liquids pipelines in Michigan, I know tonight we're really going to focus on the northern pipelines. In total, we have 4 pipelines in Michigan totaling about 930 miles of pipe. And that represents a pipeline that we're here to talk about tonight across the northern system, Line 5. We also have pipe that traverses down in our 6V pipe in southern Michigan, along with 2 pipes that feed markets in Detroit and Toledo. That being Line 17 and Line 79. Looking more specifically at the northern pipeline in Michigan, Line 5. Line 5 is a 645-mile pipeline. It's a 30-inch pipeline, with the exception of the Straits of Mackinac crossing, which consists of 2 heavy wall seamless pipes under the straits, and then it's back into 30-inch pipe for the remainder of the way. Its capacity is about 540,000 barrels per day, and it's a light crude system, which consists, the movements through Line 5 would consist of natural gas liquids batched with various light products, including light crude oil and condensates. As I mentioned at the start, safety is really the cornerstone of our business. We recognize we have to operate a safe and reliable system. It's critically important to us, and it's something that is a part of every day, certainly of my life and my role. There isn't a day that goes by that we don't talk about safety, and on a percentage basis for in some cases, the better part of the day is spent on safety and operational reliability, and it's that important. Since 2012, over the past couple of years, we've spent $4.4 billion in the area of reliability and safety. And I'm going to get in and talk about some of those programs as I go through here. We focus on going beyond just being okay. We really want to be industry leaders. And I think that we have involvement in a lot of different things, and when you talk about some of the programs that I show tonight, that we get involved with the development of the technology and really push to advance the technology. And during the last 10 years, we've delivered approximately 13 billion barrels of crude oil and liquids. And I can go into the safety record, which overall on the barrels is very good. I want to say that our goal and our target is zero. Zero pipeline incidents, and I think that's something that we want to achieve, and that's our focus. When you look at safely transporting crude oil, there were a number of different modes of transportation shown on the previous presentation, rail, truck, others. I think when you look at it from a pipeline perspective, there really are a number of components that contribute to safe operation. That being engineering design and the materials you start out with, whether it be the steel, the coating, the cathodic protection, those types of things. The ongoing integrity management, once the pipe is in the ground and the facilities are in the ground, how do you take care of it? How do you monitor it? Control center operations, ensuring that we're monitoring on a 24/7 basis pressures in the system, looking for anomalies and upsets. We do routine aerial patrols over every foot of our pipelines on a bi-weekly basis. And so we have a lot of aircraft in the air. Some of you may see them and doing their thing, but we would be, looking at right away, looking for any problems that can be seen from the air, any third-party activities going on, whether it be excavations and things, to really keep an eye on that. And then finally, really looking at emergency response in the event that there is a problem. How do we respond? Are we trained and qualified? And it's an important part of what we do is making sure that we have the training, we have the plan in place, and we are conducting live drills. And when you look at our operations in Michigan, we do have response plans, tactical response plans, which lay out where the boom would go along shorelines, where it would go, where your access points would be, and all those things mapped out in a tactical response plan for not only the Straits, but for other significant water crossings. When you look specifically at the Straits of Mackinac crossing, it really starts with the design of the system. Back when the pipeline was constructed in 1953, it was an extensive engineering project. It was one that took a lot of attention and focus. It was done by probably the leading energy or engineering company in North America at the time, Bechtel Corporation. And it included peer reviews by the University of Michigan Department of Naval Studies and another university to really make sure that we were getting the design right. And I think, as we sit here today and look at the current state of the pipe, we look back to that design as being, vitally important to that system. Safety in the Straits involves inspections, and I'm going to talk more about that later, so I won't go into a lot of details, but both inside the pipe, understanding what's going on, and also outside the pipe, understanding what's going on with the environment. It involves automatic shutoff valves across the Straits. In the event that there's a pressure drop, our control center operators would be monitoring that. In the event that that pressure drops, those valves are shutting immediately. sequencing a pipeline shutdown as an important safety feature. We have remotely operated valves, which our control center operators can operate. New leak detection equipment and technology, really wanting to push the envelope on how small a leak we can detect in the operating pipeline system, what new technologies exist out there. And there are a number of them, and we've got a department which is their day job is to focus on making sure we've got the latest technology. We've got electric backup generation at the Straits crossings to make sure that we can shut the valves even in the event of a power outage. And we've come up with and always looking to improve from a secondary containment perspective of identifying areas where we can put in secondary containment, which will keep a leak from a facility or a pipeline from migrating. And that's something we're in the process of implementing at the Straits crossing. So some very comprehensive programs at the Straits. When you look at the design and the engineering that went into the crossings and the philosophy that went into putting in two 20-inch pipes versus one large pipe, and I'll note that the pipe that was chosen was a heavy wall, near an inch thick pipe that was seamless construction in the manufacture to really focus on reducing the potential of a problem in that very, very sensitive area. A problem in that area isn't good for anyone, and certainly it's something we're very focused on preventing. Here is just a depiction of our pressure across the Straits. The pipe, as I said, is about an inch thick, 20-inch diameter, seamless pipe, tested to 1,700 pounds. It was tested again as part of the installation, post-installation. So we defined the upper limit of the testing at 1,700 psi. We've established a maximum operating pressure of 600 psi. So we said we're not going to go over 600. And the pressures you see in that pipe today across the Straits are generally under 200 psi. So operating some very substantial pipe in a very, very low pressure system. And that operating range would range anywhere from 0 to 300, but on a daily basis, if you were watching those pressures, generally sub 200. I mentioned early on that we spent $4.4 billion over the past couple of years, and one of the big areas is just in our integrity and operational reliability programs, really taking a look at all of our pipelines in our system, doing extensive, literally hundreds of inspection runs through the pipes, identifying any anomalies that are detected, going out and doing literally thousands of digs like the one you see on the map here, where we dig it up, we map anything you can see on the outside of the pipe. We do UT analysis to see any metal loss on the inside of the pipe, and do a comprehensive job of evaluating that. And if needed, we would apply a sleeve that would be welded to repair the pipe. And we do that across our entire pipeline system. There's been a lot of talk about our incident in Marshall, Michigan, which was certainly one of the low days in our organization, and it's one where we've done a lot since then. It's been near 4 years now. We've invested a lot, and some of the things, I wanted to specify exactly some of the things we've been working on since Marshall. Our pipeline and facility integrity, the previous slide I showed, really literally hundreds of tool runs done in the various pipeline segments, which drove out thousands of integrity digs, and really a comprehensive plan to look at all those, and what the renewal will be on doing more of that inspection is key to our efforts from an integrity management perspective. Leak detection, we have a department today that's dedicated, their day job is to make sure the leak detection that we have, which can include a mass balance where we are measuring what's going in, what's coming out, and the difference, to things like smart ball technology, which puts a small a ball through the line, a couple of them, and detects acoustical sounds, to other emerging technologies. Pipeline and control center operations. This is one area for us that we've seen tremendous change, including a new facility. We are operating today out of a new facility. We have new procedures for our control center operators and how they operate the lines. We have new personnel. And our control center operation is now its own department. It has its own lead. It is fully accountable for the job that they do. And we have new personnel in the form of operators and enhanced oversight and training within the control room. So big changes in that area. Public awareness, certainly looked at increased focus on our public awareness, making sure people know where our pipelines are, what commodities they transport, what to do in the event of if they detect anything, and that leads into emergency response. And really, we've created an Enbridge-wide emergency response team, pulling members from any department within the company, making sure they're trained to ICS standards, 100, 200, 300 level ICS training to make sure our team is ready. And then exercises, making sure we're getting out. We've got a big exercise coming up in Indian River in September, which is going to be a large effort. It's going to include Coast Guard, EPA, and others to make sure that we're looking at and exercising a plan. And it included a $50 million investment over the last 2 years in our emergency response equipment, just upgrading and making sure we had the right skimmers, booms in the right location, those types of things. And then finally, we undertook a safety culture review to look at the culture within our organization and were we looking at safety right. And we brought in a third-party expert in the area of safety and a company that's well-respected in the industry. We had them do a survey. We had them go out and talk to our field people. We had them talk to our supervision. We had them talk to our leadership teams. And we really drove out what is the safety culture at Enbridge and what do we want it to be. And we're in the midst of going through that. And it's something that's very important to us. So I'm not sure what I'm doing on time here, but I suspect I'm probably going long. A few other key points I wanted to touch on. Internal inspections. We run internal inspections, and I would say multiple technologies. And on the metal loss, the MFL tools, and making sure we're looking for any corrosion inside or out. We're running the new and latest crack detection tools through the pipeline systems, which uses basically medical quality ultrasound on the pipe walls to make sure we're understanding and identifying any cracks. We also have tools to identify any dents, buckles, gouges along the pipelines so that we can go in after the fact and identify those. And that's an emerging area which we've invested millions in to make sure that we're pushing the envelope in terms of what can be detected from inside the pipe. And specific to the Straits of Mackinac, we're also conducting external inspections of the pipe on a biannual basis. So every 2 years we're doing a full inspection of the crossings. We've developed and are in the process of both remote operated vehicles that we've been using. We're also working very closely with Michigan Tech in developing an autonomous underwater vehicle which is able to traverse the pipelines and get good quality data on spans and things like that, and anchors and supports along the pipeline. And then finally, we do aerial patrols of the pipeline. I mentioned already on at least 26 times per year, and then more in areas if warranted. And any of our field representatives, our field people, if there's a cause for needing to shut down and bring out aerial patrol to fly a line segment, they're authorized to be able to do that. And then finally, we're also able to get all the foot patrols. So what does that do in looking at the pipelines? What benefit is there to residents of Michigan? We have this pipeline crossing northern Michigan, but what are the benefits? And I want to just talk real briefly about some of those benefits. In 2013, we paid approximately $21 million to the state in the form of state property tax use in income taxes. We employ approximately 250 employees and contractors in the state at 24 locations with an average annual salary of $82,000 per year. As far as the commodities transported in the pipeline, it is our light line that's coming across northern Michigan. We do transport NGL, which is used for propane. It's pulled off, and the propane is extracted from the NGLs to provide propane for Wisconsin and Michigan. And then finally, our pipelines do act as a conduit for the growing Michigan oil production and some of the development that's happening, and being able to put the oil onto our system and move it out of the state. And just a couple of quick points before I wrap up, and that's just around our emergency responder education. We starting with the fire departments and broadening out, we've developed an emergency responder education program. It's an online training program. It's free for pipeline emergency responders, and it's one that we greatly encourage first responders to go through, and it really helps to establish what are the basics of gas and liquid pipeline operations, what are response tactics, and as an incentive, we provide each organization with a $250 grant on an annual basis if they have employees that go in and do this training. And we've made this available to about 8,800 first responders in the U.S. and Canada, with about 1,200 have completed the training. And that's all part of our community investment program, which for first responders, in a lot of cases, there maybe isn't funding for some of the emergency response equipment, or some of it may be pipeline specific, which is only used in response to some of our facilities. So we've provided a grant program which provides grants of $750 to $1,500 per year, and in 2013 that represented about $70,000 to the state of Michigan through applications to that grant. So in conclusion, I just really wanted to mention that we've been operating Line 5 across northern Michigan safely for more than 60 years. And we are more committed today than ever to the safety and operational reliability of that system, and providing that vital link to the state of Michigan and beyond. And I do sincerely want to thank, again, Jennifer Grunetta and the tip of the mitt for pulling this together tonight and giving us the opportunity to be here. So thank you.
Thank you, Brad. Last but certainly not least, we have Ralph Dahlhoff from the United States Environmental Protection Agency. Ralph is EPA's pre-designated federal on-scene coordinator for the northern, lower, and upper peninsulas of Michigan. His job is to coordinate and direct the dischargers' response to cleanup of oil and hazardous material discharges which threaten the inland zone. When responsible parties are not liable, he coordinates and leads government response activities relating to the incident. From 2010 to 2013, Mr. Dahlhoff coordinated all response and cleanup relating to the discharge of oil to the Kalamazoo River from Enbridge Line 60. He brings considerable insight and perspective about many pipeline spill response and preparedness issues to this evening's event.
Thank you, Jennifer. So when is the response necessary? According to the Clean Water Act, the discharge of oil is prohibited if it occurs in a harmful quantity. What's a harmful quantity of oil? The harmful quantity is oil that is discharged that results in the occurrence of a sheen on the surface of the water, or the occurrence of a sludge or an emulsion below the surface of the water. That's not a very high bar. It's not very much oil. That's what prompts the need for EPA or the Coast Guard to conduct or to supervise cleanup activity. Who is responsible, EPA or the Coast Guard? The federal regulation that I'm going to predominantly discuss in the next few minutes is called the Oil and Hazardous Substances National Contingency Plan. It is what describes who is responsible for making sure that oil is cleaned up when it is discharged and how that process is to be conducted. The Federal On-Scene Coordinator is the entity established by the National Contingency Plan to be at the tip of the spear. They are the spokesperson, the representative of either the EPA or the Coast Guard. So as I proceed through this presentation, wherever you see On-Scene Coordinator or Federal On-Scene Coordinator, that refers to either U.S. EPA or the U.S. Coast Guard. And it's really pretty simple. If the spill occurs inland and affects inland waterways, EPA is the on-scene coordinator. If the spill occurs offshore in a coastal zone or threatens a coastal zone because it is so close to a coastal zone, the U.S. Coast Guard is the federal on-scene coordinator. In northern Michigan, almost every discharge of oil, nearly always there is water potentially affected. And because of the proximity of the rivers and streams to the lake and their contiguousness, EPA and the Coast Guard are almost always working together on discharges in northern Michigan. So while one of us ultimately will emerge as the designated lead, we always are working together cooperatively to make sure that the spill is appropriately addressed. So the idea is, and the name implies this, is to coordinate. The on-scene coordinator, whether it's EPA or the Coast Guard, coordinates with all of the other local state agencies and tribal entities that have to be involved and who are affected. The National Contingency Plan also requires the use of a coordination system known as the Incident Command System that Brad and others have referred to tonight. And this is the same type of response system that the wildland fighters use out west on wildfires, that FEMA employs in the response to hurricanes. The idea is that when responders come into a response, they all speak the same language, the same lingo, the same terminology, so that they can quickly organize and get to the job rather than figuring out how to get organized. EPA and the Coast Guard both have a strong obligation during response to oil spills to keep the public and other stakeholders informed. In some cases, in this slide, the operative term is direct. In some cases, particularly relatively minor oil spills, EPA and the Coast Guard will monitor the activity of the responsible party. But in other spills, what we call substantial harm discharges, EPA and the Coast Guard are not only authorized to direct the cleanup activities, we are obligated to direct. We don't have a choice. We are there to direct the cleanup activities. A substantial harm discharge is one like the spill into the Kalamazoo River in Marshall. That will be a prime example. And while Congress, in promulgating the NCP, contemplated that they wanted the on-scene coordinators to have absolute authority in dictating how responses occurred, they at the same time encouraged, and this is embedded in the NCP, that it be done cooperatively and in a way that achieves consensus. So that's an important principle embodied in how we do response. And that's what this slide represents. So EPA and the Coast Guard are in charge of the cleanup. We try to do it using consensus, and that is what's provided for in the National Consensus Plan. However, under the Clean Water Act, we also have what's called Clean Water Act 311 Enforcement Authority, and we issue administrative orders. And that's not a cooperative thing. That is a unilateral, you have to do this way in this amount of time, etc. So there's quite a bit of teeth in the regulations and the statutes that govern oil spill response that EPA and the Coast Guard administer. So conceptually, these are the response priorities: safety of human life, stabilize the situation, and then stop it and clean it up. It's really pretty simple, and this pyramid reinforces that. And it's obvious. I mean, the first thing you always worry about human health first, then you worry about getting your arms around it, and then you put together a plan for cleaning it up. So when it comes to the cleanup phase, you've got several, or the cleanup stage, there are several phases of that. Obviously, discovery and notification. And then you've got preliminary assessment. You have to go out and figure out where the oil is, what resources have been impacted and affected, how is it moving. You have to sculpt it. You have to figure out what it is you have to operationally attack to clean it up. So when I say this, I'm not thinking so much about a few hundred gallons, in a pond. I'm thinking about thousands of gallons in a river or a lake or an ocean. So once you do the assessment, you implement the response activities, and then you do the documentation and the cost recovery and the paperwork that goes with it. So assessment is the first step. And as part of assessment, this is very important, and so I'm going to have several slides on it. The on-scene coordinator with the EPA or the Coast Guard are required to consult with the natural resource trustees. These are the people at the federal level, including these federal agencies, at the state level, and at the tribal level, who are charged with being the shepherds or the sponsors of our natural resources, whether they're land, animals, aquatic organisms. Oil spills impact natural resources, and these entities have to get involved early in the response. And so, as part of the assessment, EPA and the Coast Guard involve these entities right away. It's critically important because they help us figure out what's worse, the effect of the oil spill or the effect of the cleanup. It doesn't make sense to go in and dig up the shoreline to get every last drop of oil if we kill everything in our way just to get that done. And that's where the natural resource trustees really help us a lot. The other very significant role that the trustees have, or has, is to document the effects of the oil spill so that reimbursement or restoration and recovery can be sought from the responsible party, and that's a big deal. Pretty much what I just explained. So again, we immediately take defensive actions to stabilize it, Remember this slide, because when we go to the questions, there's going to be, there are some questions that we'll refer back to this slide for. There are, when you do cleanup and response, there are many natural processes which affect how oil behaves in the environment and how you do recovery. And many of these go to what we call weathering. So we'll talk more about these processes as we proceed. But oil spill cleanup generally involves applying physical methods like use of absorbent materials, flushing or pressure washing, raking, bulldozing, excavation. It involves protecting targets that you don't want to get oiled using booms. It involves the use of booms and vacuum equipment and skimmers to contain oil and then to pick up what you have contained. These are common tactics. Here's an example. The photograph is this is an iconic shot from the downstream extent of the Kalamazoo River spill in Marshall. This is at the downstream end of Morrow Lake, and the Chevron booms were put there as a last ditch or as a last effort to make sure that nothing got over past the final dam in Morrow Lake, which was about 35 miles downstream of where the break occurred. The EPA and the Coast Guard are also the ones who determine what types of alternative countermeasures might be employed in the event of a spill. Whether you're talking biological agents in the case of an ocean or marine spill, in situ burning, or a decision to go with natural attenuation. Recovery and rehabilitation of wildlife is a very big component of spill response. So part of our job, part of EPA and Coast Guard job, is to determine whether the responsible party is capable of doing the work, whether they're financially viable. And if they're not, then it's possible that we make a decision to federalize it, to assume control of it. And as I said at the outset, that last bullet, in the event of substantial threats, we are obligated, we shall direct. Who determines when the cleanup is done? Who determines how clean is clean? It's the federal on-scene coordinator in consultation with the governor of the affected state. And what that means is that the federal on-scene coordinator in the state of Michigan would coordinate with the Michigan Department of Environmental Quality throughout the recovery to say when we're done, when enough is enough, and when EPA will transition it to the state. We also work with NGOs, state and local partners. Just as Brad Shamblon with Enbridge discussed the importance of safety, pursuant to the NCP, EPA and the Coast Guard are ultimately responsible for the safety of all of the workers on the response. And we are also responsible for coordinating with the health agencies and the local emergency management agencies to ensure public safety. Public safety can very often be a real issue, particularly in the early days of the response, particularly when there are large volumes of oil, any kind of oil, whether it's tar sands oil, gasoline, cooking oil. When you have a lot of oil on the ground, you can have public health issues, whether they be air issues or water issues, and those are paramount. And obviously we have documentation and reporting functions. Finally, I'll wrap this up. The other major task that the National Contingency Plan requires EPA and the Coast Guard to implement is what we call area planning or contingency planning. I don't have enough time to get into the details of it, but there's a national contingency plan, and then there are area plans, and there are sub-area plans. In our case here in northern Michigan, there's a sub-area which covers all of the northern lower and half of the UP. That is the area that I and Steve Keck with the Coast Guard, Steve in the back. Steve is the lead planner for the U.S. Coast Guard out of Sector Sioux. Steve is heavily involved in working with all the northern Michigan agencies on area planning. Since I've been back in northern Michigan, since working on the Ambridge spill, I've been working closely with Steve to try to get up to speed on the area planning that he has going. And all of the state agencies and local agencies that are in the room tonight and will be at the table are also involved in the development of these contingency plans, these sub-area plans. These plans can be found at these website links. The first one is www.rrt5.org. RRT stands for Regional Response Team. And then there's also the National Response Team website, and everything that you would want to know about contingency planning and oil spill response is available to you on both those websites, including the specific sub-area plans. And so the Northern Michigan Area Contingency Plan is available to you on that website. There are also some other interesting documents, such as the inland sensitivity atlases, which are collections of all of the sensitive areas that could be impacted by oil spills. Those are available to you as well. And then finally, there's a lot of information on EPA's website about oil spill response. So my goal here tonight was to do a 10-minute introduction to the who, what, when, and how. And things that I missed, I'll try to pick up in my participation in the panel. So thank you very much.
Panelists. Hello, panelists, if you would come up, thanks. So folks, we're running exactly a half hour behind schedule. So we will go through.
Down there judging ineffectively. You can't clean that spill. You'll never clean that spill. Your worst case scenario here is a 2-minute spill. You've never in your history had a 2-minute spill. The Kalamazoo is 17 hours. I thought maybe these people would get some honest answers here. This is a beautiful town. It'll never be the same if that pipe right in the strait spills. You know it, I know it, the people in Kalamazoo know it, and every other person in this nation has to deal with it. Has to deal with that.
Okay, thank you. Hey folks, I'm Bernetta Tomasi, Program Director at Tip of the Met Watershed Council, and again we thank you all for coming tonight. And I want to give a special shout out to some members of the Watershed Council who just returned for the summer. I'd like to welcome you back. Good to see you at our first big event of the season. So this topic is one that both our members and the community at large have become very interested in. That's why we searched for a venue that could hold many people. It's also the reason we included the information booth session to give you a chance to talk to the parties involved one-on-one. Now we begin the question and answer portion of the program. As you know, we asked you to submit questions for this panel ahead of time when you registered. We received nearly 100 very thoughtful and relevant questions, and we really appreciate that. We obviously will not be able to get to all of those questions tonight. So we, at Tip of the Met Watershed Council, we grouped your questions by topic and accounted for duplicates. We then coordinated with the panelists to ensure that many of your submitted questions were answered during the presentations. And then we prioritized the remaining questions based on those asked most frequently, as well as those specific to our mission to protect water resources in northern Michigan. So please note this. Even though we expect to run out of time, we will do our very best to help you get answers to the questions that we can't cover tonight. First, we are providing cards for you for additional questions that you may have or questions that were not covered. If you include your contact information on the card, we will follow up and help you get the best information that we can find for you. And this will include trying to get follow-up written answers to the questions, and we'll also connect you directly with some of our panelists to provide you with answers. And we may host another event, more like a workshop in the future. We recognize this system is imperfect, but we're trying to provide as much information as possible, and we appreciate your understanding. However, between the presentations and our Q&A, we should be able to address the majority of the submitted questions. And I do want to say, we've also passed out the questions that we're going to ask here tonight. There's 22 of them on that list. But after we saw some of the presentations, then we took a few off and added some that didn't get addressed that we were hoping they would address. So we've got a couple of questions 1 and 2 are new. They're not on the list. Your list will begin with 3, and then some of those questions will be asked. Okay, so without further delay, let me introduce the panelists for the question and answer session. We have Brad Chandler, as you met, from Enbridge. John Griffin is Executive Director with the Associated Petroleum Industries of Michigan. Alan Beshore, you met, one of our presenters from PHMSA. David Chisla, Manager, Gas Operations Section, Michigan Public Service Commission. And then we have Joe Haas, Supervisor of the Water Resources Division in the Gaylord Office of the Michigan Department of Environmental Quality. Ralph Dahlhoff, our other presenter, Federal On-Scene Coordinator for the EPA. And then we have Steve Keck, U.S. Coast Guard Sector Sault Ste. Marie. Randy Roth, Supervisor, Remediation and Redevelopment Division, Gaylord Office of the DEQ. Greg Williams is the Director, Tri-County Office of Emergency Management. Mike Jones is here, Environmental Health Supervisor with the Health Department of Northwest Michigan. Then we have Bill Hazel, Director of Marine Services for Marine Pollution Control. Beth Wallace is a board member of Pipeline Safety Trust. James Clift is the Policy Director of the Michigan Environmental Council. And Jennifer McKay is Policy Specialist at Tip of the Met Watershed Council. So we're going to start with our first question, and it will be for Enbridge, and that is or will diluted bitumen or dilbit be transported in Line 5? And there is a quarter one as well.
Thank you, Renetta. So if I understand the question, you said, will diluted bitumen be transported in Line 5? And the answer to that is no, it will not.
Okay. The second question, also not on the list, is for PHMSA, and it's, what is the notification process to the public and local, state, and federal governments if Enbridge starts transporting another commodity, such as dilbit, through Line 5?
Well, under our definitions of crude oil includes diluted bitumen, so they're required to file annual reports every year, but it'll be under crude oil, and then crude oil includes diluted bitumen. So.
Okay. All right, so then a follow-up for Enbridge. What is synthetic crude? Does it differ from diluted bitumen or dilbit? And does synthetic crude sink if spilled in waterways?
So synthetic crude would be partially refined crude oil, and so it would be upgraded crude oil that goes through a chemical process to create a synthetic crude, as compared to dilbit, which is simply a blend of a condensate in a bitumen in a dilbit, or a diluent to make dilbit. And the answer on the synthetic crude is, it is considered a light crude, and specific gravity would be significantly less than water, so yes, it would float.
float.
It would flow, yes.
I would like to follow up with that, and just ask for clarification. Is the synthetic crude, does it come from the oil sands where it is mined bitumen that is then upgraded at a refinery?
Oh, sorry. Sorry. There's a portable one in the middle too.
So you can create synthetic crude from any basin. On our system, it would come out of the Western Canadian Sedimentary Basin and/or the North Dakota system, but primarily the Western Canadian Sedimentary Basin.
I'd like to, is this on? Okay. I think this issue of whether oil sinks or floats is a complex one. It's not, I'd like to comment on it. It's not simply a matter of what type of oil. It's not a matter of whether it's a light oil or a heavy oil. That's one of the factors that we have to consider. But there are other situational factors, such as how long, what's the discovery time, what's the recording time following the spill, how long is the oil out in the environment loose before response activities can begin. That's a huge factor. Is water involved? What kind of water? Is it a river? Is it a lake? Is the river in flood stage? What's the weather like? Is it 30 degrees or is it 90 degrees? If it's 90 degrees, is the oil separating and is the heavy oil becoming lighter because the lighter part of it is, or is the heavy oil becoming even heavier because the lighter part of it is volatilizing because of the heat? These are processes that we call weathering, and that's the slide that I referred to a few minutes ago. All of these factors combine to determine how oil behaves in the environment and how it travels and how it changes and transforms, and therefore how it is recovered and how much impact and damage it has. And this, over the past 4 years, I've been asked this question 100 times. And it's kind of a mission that I have to educate people to the fact that it's about more than just what kind of oil. It's what are the circumstances. So I'll leave it at that.
Thank you. We're going to move on to the next question now. What structure supports are required for the portion of pipeline on the lake bottom? This is going through the Mackinac Straits. Do we know if the pipeline is adequately supported, and what, if anything, is being done to improve the condition of the pipeline and its underwater support system?
Yes, we do know how the pipe is being supported. We do on a biannual basis, or every 2 years, we run a remote operated vehicle to take a look at the pipeline along the bottom of the straits. And so we do identify, and each particular span is identified, numbered, and that's something that we are aware of that, and we do know that the pipe is adequately supported. In terms of how it's supported, it can be anywhere from grout or sandbags to something else. We developed a screw type of anchor that we're using on the Straits crossing, starting back in probably 2002 or 2003, which actually screws into the floor and it doesn't allow movement from the currents or anything like that. So when we do our updates today, and we are doing one this year, we would look, the repair that would be done on the spans would be done with those screw anchor type of supports. And I apologize, I don't believe I had a picture of one in my presentation, but it's something that we feel from an engineering perspective is certainly a state of the art in terms of anchoring for that pipeline system.
Okay. Some follow-up?
Joe, with the DEQ, just to be clear, the DEQ is currently reviewing a permit application for what we understand to be ballast saddles to anchor the pipeline. and that's available if you wanted to look on our QPAS database online. You can see where the status of that permit is. It's still under review.
Okay. Next question. Has Enbridge obtained authorization from DEQ under Part 325, Great Lakes Submerged Lands Act, for placement and use of the pipeline? If not, will you, and when? Also Enbridge.
So our pipeline would have been approved and constructed in 1953, and that would have predated the Part 325. So we would have had our pipeline approved under Public Act 10 from 1953.
Any follow-up?
Just that, yeah, that was an easement that was approved by the Department of Conservation that was predating DEQ, predating DNR. It's now held with the DNR, and they're probably more appropriate to speak directly to that. They hold that easement and would be overseeing that. That's really all I can add.
Okay. We're going to skip the next question on the printed page and go to the next one. What is the expected life of a pipeline like the Enbridge Line 5? How is this determined, and are the supporting engineering studies available? That would be for Enbridge.
Yeah, so pipelines are monitored on a very regular basis. I mentioned in my slides some of the internal inspections that are done looking at condition of the pipe. The longevity of the pipe is really determined by the condition of the pipe and how it's holding up, and we're able to monitor through the use of those tools. So I think for every pipeline it would have a different life. It would be based on what was the initial design, how was the pipeline operated, how was it maintained, what were some of the design materials that have gone in. And all those factors would determine the fitness for service of the pipe, and that would drive any decision that we would have around replacement of a pipe segment.
Follow-up?
Yeah, just kind of as a follow-up to that, the thing to keep in mind is that the steel itself doesn't age, if you will. I mean, the wall thickness may be reduced because of corrosion, but if you can mitigate the corrosion and prevent that from happening, the strength of the steel doesn't just change over time. Now, certain vintages of pipe have had construction problems. For example, pre-70 low-frequency ERW pipe has had issues with seam integrity, longitudinal seam integrity. So we've addressed those issues by focusing on mitigating that threat long term, and not necessarily just because of the age of the pipe, but because of the vintage of its manufacture. So if you focus on the threats to the pipe and not necessarily the age of the pipe, if it's properly maintained, it doesn't wear out, if you will.
Specific to fine?
Yeah, I do have a quick follow-up question. It's been mentioned several times that this pipeline is seamless. I think that's a little misleading because there are segments of pipeline at the Straits location that need to be welded together. And I wondered how Enbridge has been monitoring the welds and how frequently, and is that something you can do when there's sediment on top of the pipeline?
Yes, very good question. And in fact, there are welds, circumferential welds, welding joints of pipe together. Typically, when you're talking about pipe seams, it's longitudinal, running the length of the pipe joints. So there would be no seams in the pipe. There are pipe joints, and yes, we do inspect those. And in fact, in 2014, we'll be doing what's called a tethered tool through the segments, which will look at each pipe joint from the interior, and it'll use the latest technology in crack detection to monitor each weld through that segment.
Okay. Looks like we're great. We'll be coming back to you. And next question is, how many regulators are there to monitor safety of pipelines across the country, and specifically, how many for Michigan? And this will be for FEMA.
We're approved, I think, for a total of inspection of enforcement personnel of close to about 140 nationwide. Like, as I mentioned, I'm out of the Kansas City regional office. There's about 25 of us, I think, Region office. There's a couple, we actually have an engineer inspector that actually lives here in Michigan, but we don't necessarily assign folks a specific geographic area. They're assigned activities for inspections or failure investigations and things like that as they come up. Now, to supplement that inspection staff, as I mentioned in my presentation, we work with the states, and so there's an additional 300 or so is the number that I'm remembering of state personnel that do the inspection and enforcement activities for the natural gas distribution systems in their states.
Yeah, I'd like to follow up with that. Specifically in Michigan, like Alan said, we do the inspections for the natural gas pipelines. On the interstate pipelines, we do inspection. We turn our inspection results over to PHMSA, and they do the enforcement. On the state's pipelines, the intrastate pipelines, we do inspection and enforcement. And currently, we have 8 full-time engineers in the state that are dedicated to doing pipeline inspections specifically to the natural gas pipelines.
Okay. Anything else? All right. So next question is, why does the state not have authority over oil pipelines in Michigan? And has the state of Michigan considered taking over authority to improve protections for our Great Lakes and other water resources?
Again, I'll take that question and specifically talk about, yes, there has been consideration, but it would take a legislative process. We would need to have a law in place for us to specifically regulate the intrastate lines. And we could do that. There's an additional program with PHMSA that we could take over responsibility for that. Currently, there is no law that gives us the authority to do that. So prior to being able to do anything, we would need the authority under some statute to be able to do that.
Okay. PHMSA, you want to?
No, I guess just to kind of clarify, all the interstate enforcement activity, whether it's done with Dave's personnel and under that cooperative program with the state of Michigan, has to come out under our authority because of the interstate pipeline status. So that's why we have to do the enforcement, even though they can do the inspection activities and then plan and bring that to our attention for us to follow up on.
Okay. James, did you have a follow-up?
Yeah, my understanding that there's certain kind of levels of oversight that a state can undertake, certification, other things. Can we get a little explanation of kind of the different levels that different states are authorized to undertake?
I'll take the first stab at that. There's specifically, with regards to pipeline safety, there's 4 programs. There's 2 for liquids and 2 for natural gas. And they're split between interstate and intrastate. And in Michigan, we just have the 2 programs for the natural gas. So we have inspection of the natural gas interstate lines and inspection enforcement of the natural gas intrastate lines.
I'll just follow up a little bit on that. It's much more common for states to extend over the interstate natural gas pipelines than the ones that adopt the authority and get involved into the hazardous liquids pipelines side of the thing, because there's 2 different regulatory parts that are involved, and so there's additional training and things that they need to get involved in to do the hazardous liquids pipelines inspection and enforcement. In Central Region, the only state that does hazardous liquids is in Minnesota. Minnesota does inter and intrastate, both natural gas and hazardous liquids pipelines. But none of the other, Indiana adopted authority over intrastate hazardous liquids pipelines just in the last couple of years because of some short carbon dioxide lines that they wanted to take responsibility for. But other than that, the Central Region, all the hazardous liquids pipelines are inspected by us.
Beth, did you have a follow-up?
Yeah, just to point out, the reason why it's great to have the state do certification or take on this authority to do inspections is obvious. Obviously, the NPC is familiar with the area and local and easy to contact, and it's also a huge transparency point. It's much easier to get information and to communicate with our local state authority versus managing the federal system.
Okay?
And-
Next, oh, go ahead.
I'm sorry, I would just like to add,
Yes.
as far as the DEQ goes, under the Natural Resources and Environmental Protection Act of 1994, it's Public Act 451, we would have authority as far as DEQ goes for the placement of structures in wetlands, inner lakes and streams, or on Great Lakes bottomlands. So in the modern era, we do have authority under any structural placement in those sensitive areas.
Okay, thanks. All right, next question. Enbridge did address some of this in their presentation, and we'll come back to them, but we're going to start with PHMSA. And we wanted to hear the answer to this question through the eyes of the regulators. So the question is, what lessons were learned from the Marshall spill? We'd like to hear from PHMSA and EPA on that. Could you start with that?
Sure. In fact, I was reading an advisory bulletin we just issued last month, or well, a couple months ago in April, outlining some of the lessons learned for the rest of the industry to take into consideration in their programs. And so I refer you to that. I laid it down somewhere so somebody maybe read it now. I don't know. But anyway, I don't have it in front of me, but I'll refer you to our website that's out there. And it summarizes some of the things that some of the deficiencies that were identified by that investigation, and some of the things that we've been doing to try and address those deficiencies. And, Brad talked about what Enbridge is trying to do. We were involved in also out on the website, there's a corrective action plan that addressed the Lakehead system that we've been working, overseeing with Enbridge on. But the other thing is we're trying to apply those learnings to the industry as a whole. And so some of the deficiencies that were identified, for example, with the review of the spill response plans, we've staffed up our group that reviews those plans and approves them. We've gone through and we've reviewed a bunch of those, and we're releasing those out into the public website. So if you go to our website and go into the FOIA reading room, there's some 60 plus spill response plans that have been reviewed and approved and posted there. And there's another, I think there's a total of 300 and some. So we're in that process of getting that information reviewed and approved and released in a public version. Some of the things that we have rulemakings underway as part of the Act of 2011, there was a lot of studies that we had to do. Some of those were prompted by the Marshall spill. Some of those were prompted by the accident in San Bruno, California, that you may have been aware of as well on the natural gas side. But some of those apply. There's consideration of leak detection regulations. There's a docket underway to look into that. There was a report that was done on leak detection systems for Congress that's on our website if you're interested in reading that report. There's a study that was done as part of that act on remote control or automatic shutoff valves. And so that report is on our website, and that's you can read that if you and that's part of the docket considering additional rulemakings as we go forward. There were some issues with the control room, and as a result of the Kalamazoo spill, we implemented, or we came out with a set of regulations for control room management that addresses issues like fatigue and alarm management and some of these other areas of control room operations that previously didn't have any regulations involving them. So we've done that. We're looking at, as part of our integrity management reviews, we've tried to come up with additional requirements for performance measures so people can measure the improvements that their systems, or if there's the opposite of improvements. Anyway, so they can measure, they have meaningful metrics to measure their programs and whether they're effective or not. We've actually gone through there was public awareness activities were mentioned, and we have some relatively new requirements for public awareness. We've gone through, we've inspected all the pipeline operators in the country and done the first round of inspections on those regulations. So there's been a lot of activity that we've done as a result, not as a result, but since that accident occurred.
Thank you.
So I'll pick up on the public awareness lesson. I was talking with someone before the session at my table out front, and I mentioned this issue as a major takeaway from the Marshall spill. We all know there were delays in reporting and notification of the release, big delays in response time, and that allowed the oil to travel a long distance, 2 miles, to get into the river. And Alan and Brad have both talked about adjustments that Enbridge has made. It's ultimately it's Enbridge's or the pipeline operator's responsibility. However, in the Marshall case, there was a low level of community awareness. For many hours, there were signs in the community that something was happening. People smelled it, they were calling the police, they were calling the fire departments. Nobody could figure it out because the public wasn't aware that the pipeline was there, and the first responders weren't sufficiently aware. I don't think that's going to be the case up here. I think there's a good level of awareness, and I am encouraged to see that. I think that's really important because I'm not suggesting that it's the community or the public's responsibility, but it is to your benefit to be aware. And I think that's a major takeaway. Other takeaways, and they're related, include the use of conventional technologies. In the case of Marshall, within the first few weeks of the spill, over 760,000 gallons of oil were recovered using conventional response techniques. Booming, skimming, vacuuming, excavation. Not rocket science. The same thing, the same way we cleaned up oil spills for decades. Now, in the case of Marshall, we had a sinking component, and that occurred progressively as the oil weathered, and ultimately it became about submerged oil. And the lesson there is that you want to get, in cases where you know you have heavy oils that you might sink, you want to get submerged oil containment in as soon as possible, in the same way that you get surface oil containment in. Okay? And then finally, if you're dealing with submerged oil, you have to get the science going early. Over the past 4 years that the Marshall response has been ensuing, there's been a lot of heavy science applied in modeling and monitoring and geomorphology to predict how submerged oil behaves and moves. And if you don't get that going early, it's not available to you down the road when you need to make decisions about how to clean stuff and where is the oil. So I'll leave it at that. Thank you.
Okay, yes.
Just one quick follow-up to that. I think the lessons learned are just vitally important, that we take the time kind of as we go through it to make sure that we're learning from it. And I think as humbling as it is for us, I think sharing some of those experiences with other pipeline operators, making sure they understand. And I've personally got phone calls from others dealing with situations where they've asked me questions about our incident. And I think those lessons learned are just critically important.
Okay, yeah, go ahead.
Yeah, one thing I wanted to add to that was that a panel was given at the International Oil Spill Conference not that long ago in Savannah, about a month ago, that Ralph actually moderated. And the Marshall spill was one of the primary case studies that was discussed there. But one of the clarion calls that I think came from that panel was that all of those lessons learned start to be integrated into the response planning mode, into the area contingency plans. And some studies be conducted of those response capacities within these regions, how these oils may act, and some pre-planning in that regard. So there is a forward movement in that I think Ralph championed there at the International Oil Spill Conference, and one of the speakers addressed that specific issue. So I'd like to put that forth as one of the directions that we're moving as oil spill responders, and getting that into the planning phase instead of the reactive phase.
Great, thanks. All good? Go ahead.
I just want to echo the community awareness. I'm from the area that was impacted. There's several people here that were impacted directly, and it just Enbridge in particular, or any pipeline operator, just being involved with the community, talking about resources that could be impacted if there is a spill. And I also think, earlier there was a discussion about bringing in the trustees for the natural resource damage assessment process post-spill. Why not bring them in pre-spill and talk about contingency plans and areas that need to be addressed, specifically for locations that are of high consequence, very high consequence. I also want to ask a question. I'm sorry, I'm going to be very quick. I know there was a corrective action order following the Marshall spill. There was also a corrective action order following the Grand Marsh, Wisconsin spill, which was system-wide for the entire Lakehead system. And my question is, has that one been resolved? Is it completed? If not, why or how can system-wide expansions continue to occur on the Lakehead system when a corrective action order is in place?
Portions of that plan have been completed. It was, I don't remember the exact number, but there were some 13 different topic areas, if you will, of that plan covered, and some of those have been completed, some of those are ongoing, and I don't know, honestly, the current status of many of those. One of the conversations that I have quite a bit with people that they don't understand is that our regulatory scheme talks about operating pressures because operating pressures are what causes the stress on the pipe. Now, their capacity changes can occur without ever increasing the operating pressure on the pipeline. So the maximum operating pressure on a pipeline segment is established by a regulation, but not specifically even Enbridge, but historically many companies, when they installed a pipeline to begin with, they would go ahead and buy a parcel of property halfway in between compressor stations, for example, because they anticipated that the capacity would be increased as business, transpired over the course of the year. So it's not uncommon for people to plan ahead when they install a pipeline and then come in and add compressor stations that were basically planned all along in between existing compressor stations or in between pump stations. The maximum operating pressure was established by rule, by regulation, in accordance with those regulations, but the capacity is increased by that additional horsepower or pumping capacity. One of the other ways that capacity can be increased is by a drag reducing agent, which decreases the friction along the pipeline wall, and so the product, it takes less horsepower to move the product. So it doesn't fall under our regulatory scheme because they're not revising their operating pressure upwards to where it would exceed what their maximum has been established at.
Are you okay? Yeah? Okay. Steve?
Now, it does affect the emergency response planning, and that probably was what this gentleman was going to talk about, because their facility response plan is based on a worst-case discharge. And so if their capacity is increased, there would be an increase in their worst-case discharge potential, and that would have to be accounted for in their planning purposes.
Go ahead, Steve.
Yeah, I just wanted to point out your question there about pre-planning, contingency planning. I am the contingency planner for the U.S. Coast Guard for this AOR, and we do contingency planning. And in fact, we just had our last area committee meeting on Thursday, which consists of 66 different agencies throughout the local area to include federal, state, local, tribal, academia, industry. They're all involved in that pre-planning. So, and we are looking forward, as pointed out by Bill Hazel from Marine Pollution Control, about non-buoyant oils. All these things are already being looked at. Oil and ice recovery is being looked at, particularly in the Straits of Mackinac. We did an exercise in 2011. We did an exercise in 2012. We did an exercise in 2013, all in the oil and ice conditions, and we have an exercise planned for 2014. So,
The tribal was the one I was wondering most about.
yeah, actually we have six different tribes, and Chippewa Ottawa Resource are all members. And our counterparts in the Canadian side also involved there, First Nations as well.
Okay. I'm going to ask two questions of Enbridge next. The next question and then the one two questions down. And you did cover some of this already in the presentation, but I think it would be good to clarify and reiterate. The first is, how are pipeline leaks detected, and how is the line shut down once a leak is detected? And then the follow-up, how long will it take to completely shut down the pipeline once a leak is detected?
So how are pipeline leaks detected? We have several ways to detect a pipeline leak. And it really starts in our control room with our control center operators who are watching the pressures along the pipeline system with each pumping station and looking for any particular leak trigger that they can identify from normal operation. We also have a mass balance system, a leak detection system, which measures flow, mass going in the pipe versus coming out at our designed location. And it's a continual comparison between flow in, flow out. And if there's any discrepancy between one or the other, it's going to send a trigger again to the operator or put the pipeline into shutdown. I mentioned in my presentation the location of some auto close valves. Those would be...
Enbridge Lodge, stop line 5!
Those would be, control valves would be monitoring pressure reductions. When it sees a pressure drop, they would automatically go into a closed cycle and shut the pipeline down. We also do, as I mentioned, aerial patrols. And so as we're flying the pipeline right away, and we're watching for, and I think Ralph's presentation showed some pictures of sheen and things like that. That's a water body, looking for spots along the right of way, that type of thing. And then public input, as we're getting the public consultation and people being aware of an odor, they know who to call and for us to investigate. So a number of different ways that pipelines are detected. The second part of your question is how long will it take to completely shut the line down? And the answer is very, very quickly. We have put in electric operated valves in a lot of key locations. Those are basically at the fingertips of the control center operators, and when they hit an auto shutdown, they're going through it. On a 30-inch pipeline, the valve is probably cycling shut in about 3 minutes. On a 20-inch pipeline, it would be probably about 2 minutes to go closed on that system, so it does shut down very quickly.
Any follow-up? Okay, so this next question was asked over and over and over and over again in many different forms, including one that could have opened a novel as far as the setup. But the question is, should a leak occur in the portion of pipeline in the Straits during winter with significant ice, how would it be discovered?
Yes, and so I think I'll go back to the list that I had talked about, and a lot of our pipeline, in fact, the majority of our 50,000 miles of pipe would be buried, and we wouldn't have direct access to see that pipeline. And so our leak detection efforts are really focused on how can we tell what's going on in areas we can't see. And so our leak detection, again, our mass balance system, looking for any change in operating pressures, is what we're putting in one end of the system, coming out the other end. On the Straits of Mackinac, we also have the ability, when that pipeline shuts down in a static condition, we're able to shut the valves on either side of the Straits and monitor what pressure is in that pipeline segment, valve to valve. And if the control center operator sees any bleed off of pressure, valve to valve, he knows there's something going on. So he's able to do a static test anytime the pipeline is down. And then finally, just from the overall access to the waterways and the time of the year, and we've done a number of exercises which Steve has mentioned. We continue to focus on and have responded to leaks on ice, and it presents different challenges. But again, as a responsible party, we have to address those challenges and be ready to respond, whether there's ice or not, and that's what we're focused on.
Yeah, sure.
I want to say, too, that those oil and ice drills that we did, we tested many new techniques and types of equipment that we found, some of it to be very beneficial to finding the oil underneath the ice shelf. We use autonomous underwater vehicles. We use remotely operated vehicles to go underneath the ice We use forward-looking infrared radar to detect the oil in the water column. We use an aerostat, which is basically a blimp that's tethered to give us a common operating picture and also allow us to see where the oil is in the ice. It's very, very rare, believe it or not, to have solid ice cover in the Straits of Mackinac. But the ice conditions change all the time, depending on the currents, depending on the winds. A couple years ago, we had to almost cancel our drill because there was no ice in the Straits just a couple years ago, whereas this year we have real nice ice cover to practice in. But the techniques that we're learning in the Straits of Mackinac are being used in Alaska as well. And we have become the center of excellence for oil and ice recovery techniques that we're perfecting here in the Straits of Mackinac, and we continue to work on those. Some things didn't work as well as others, but that's the reason we do the exercise, to find out what equipment does and what equipment does not work. It's a continuing challenge, and we keep working on getting better at doing oil and ice recovery.
Okay, great. Any other follow-up? Okay. So we're going to go till 9 o'clock and continue these questions here, and we'll reevaluate at 9. All right, so next question here is for the Office of Emergency Management, Greg. The question is, how would the public be notified if a leak or break in the pipeline was detected, and how quickly?
Sure, thanks. So it's important to make a distinction here between a pipeline break or some kind of leak that the pipeline company is working on versus really a catastrophic break or leak that public safety is involved in. Because there's really two different classifications there. If there's something that the pipeline company is working on, the public safety is not involved in, we may not even be aware of it unless they feel it's appropriate to call us. But that's very different. That's a stark contrast from what happens when we have an actual release. And the public notification piece of this is vitally important because in the case of this release, or really any hazardous release that we have into the environment, we need the public to help us. So we need to get that information out to you as fast as we can. We may need you to leave your home or stay in your home or do any one of a number of actions for us. So that said, we've got a number of tools at our disposal to help get that notification. One that you may be very well aware of is the emergency alert system. That's been around for a good long time, and you hear that often for severe weather and for other community emergencies. But now we've got some newer technology these days, especially if you are a resident of the Charlotte, Sheboygan, or Emmett County area, especially if you live around any kind of site that you have some concern for. I would encourage you to look into our B-Alert emergency notification system, which is a system that we have here, unique and special to our 3 counties. And if you're here, whether a business owner or a resident, or even a seasonal resident, if we have any kind of emergent public notification to make you aware of, we utilize that tool. So you can sign up for that. There'll be some information on the TIPADMIT website for you. That's a very quick self-registration, and then it's unlike the EAS system. This system actually will call you at home. It will send you a text message. It will send you an email. Any device information that you put in the system, it will find you at those devices and deliver that message to you. Thank you.
Sure. Health Department, anything to weigh in on this one?
I think you pretty much covered all that.
Okay, great. Any other follow-up? All right. Okay, next question. In the event of a pipeline failure from Line 5 or any other pipeline in the region, who responds, at what response time, and where do they come from? Realistically, how long does it take to marshal the personnel and equipment to actually start containment and cleanup of an oil spill? And we're going to go to you for this again, Greg.
So this is a pretty big question. There's lots of individual questions that are kind of loaded in here. So I'm going to take the first part of this and I think I pass it off to Ralph from the EPA to follow up on. First off, when there's a pipeline failure from any of our pipelines, it could be Line 5 or any of the other pipelines in our area, obviously it's going to evoke a public safety response. And that first responder that gets there is going to be the initial eyes and ears and boots on the ground to do an assessment as far as how bad this is. And that could be a matter of minutes. It could be a matter of several minutes. It really depends. It's hard to answer that piece of the question specifically, because there's so many pipelines in a wide variety of areas across our region. Some are very quick to get to. For example, if there is some kind of problem at the Enbridge pipeline in Mackinac City, we're going to have somebody there literally within minutes. If it's in more of a remote area and the first responders have to find it or travel some distance to get to it, it might take a little bit longer. It just really depends on the logistics and the particular area that it's in. But by and large, public safety would likely be the first boots on the ground, so to speak, to get there and do their rapid assessment and start getting some intelligence, some information as to what's happening on the ground. Ralph?
Just one clarification. I think Greg was referring to the government response and the first responder response, not including the company. I think there's an expectation on the part of EPA and the Coast Guard and Greg that the company would be the first one that would be there. And I know that Brad has mentioned that they've made some adjustments to upgrade their ability to be there. So here's how it should go. The company, the local first responders, meaning the Office of Emergency Management, police, and fire. That's almost always the way that it's contemplated. As that's occurring, there are notifications being made by the company and by the first response community to other entities such as DEQ, such as the Coast Guard and EPA, and very importantly, to the company's cleanup contractors, people like Phil Hazel with Marine Pollution Control. They are called, the cleanup contractors are called the Oil Spill Response Organizations. The acronym is OSRO. So the company, the first responders, the OSRO, meanwhile, Coast Guard and EPA are getting called and we're on the way. If it's a big one, even if it's not a big one, we're there to evaluate what it is. So that's the sequence generally, and there are many other notifications. One of the notifications that we are really encouraging and reinforcing is health departments, because oil spills always have public health ramifications. It's not just about fish and ducks and birds and shoreline. There are public health issues, and public health agencies have to be in the loop. So that's the sequence. All of what we just described can happen pretty quickly. And then it depends. It depends on what it is. It depends how small it is, how big it is. Remember the slide I showed about the phases of cleanup. The first thing you do is notify, then you assess. You have to know what you're talking about. You're talking about 5,000 gallons probably, or 5,000 with the potential for it to be 500,000. You got to know that, and you got to know where it's at. So it depends, and I'm going to let Steve take it from here and pick up with the next level, the next tier.
Right, the next level, once the Coast Guard receives the NRC report, we're going to dispatch our pollution investigators, which will head down to the Straits, which should take them about an hour and a half to get down there. We have a 13-person ICS quick reaction team that will follow them. In our area contingency plans and our geographic response plans, we have pre-identified incident command posts set up on both sides of the bridge at St. Ignace and Mackinac City. We would open up those incident command posts. We have pre-identified staging areas. We have pre-identified boat launches. We would use those GRPs and the Enbridge tactical plan to start the response immediately. Immediately we would order in more resources, and we start bringing in more and more people from District Response Advisory Team, our National Strike Team. Quickly, more and more reinforcements that show up. It would ramp up to a massive response, hundreds of personnel within that first 24 hours. But ideally, Secretary Sault Ste. Marie would have their pollution investigators down there within an hour. And like I said, that Advon team would probably be about 2 hours after that. We're also very fortunate that we have Mackinac Environmental in St. Ignace, which is fantastic. So we have an OSRO, which is right there on the Straits, which, in addition to first responders, obviously Mackinac Environmental will be the first environmental response people on the ground.
Bill, anything to add?
Yeah, please. like to start kind of like with a little bit of a metaphor here. So we kind of put our mind around this idea, but if there's an accident on a freeway, it all starts with probably one trooper and one car. And then that trooper is trained to a high level to be able to initiate a response. And that's what we're talking about here, is a tiered response. So initially we will start rolling the boom in, we'll start rolling the skimmers in, and so on and so forth, and building upon that until eventually the entire cavalry is here, so to speak. So that's the way it will look to the community. It's just like a traffic accident occurs, is that resources start to get brought in until we get our hands on this situation.
That takes time. It takes a lot of time to, well, I shouldn't say a lot of time, and that's a relative term, but it doesn't happen immediately. What we want to happen immediately is the initial response and the assessment, and then we want to get the rest of the stuff there as quickly as possible. In the case of Marshall, it took days and days to assemble 2,500 people and 200 excavators and 500 boats. It's just not all immediately available. So when you have a major worst case discharge, you have to expect that it's going to take some time to get everything rolling.
With that said, OSROs in this case, my experience in regulation in this dialectic we're discussing here, that OSROs submit, or some OSROs submit, my company does, to a voluntary OSRO classification program with the Coast Guard, and I'll share some of the ideas that go around that. In the Great Lakes operating area, within a 6-hour time period, it's my company's responsibility to maintain readiness to be able to bring, within 6 hours, 6,000 feet of protective boom, 1,000 feet of containment boom, plus 300 feet per skimming system that's brought in. Oil recovery equipment, effective daily recovery capacity in the range of 50,400 gallons per day, and storage for that of 100,800 gallons of temporary storage. That's all within a 6-hour time frame to anywhere where I am listed as an OSRO, and I am in the Great Lakes from Buffalo to Duluth. Dealing with a worst case discharge scenario, my planning standards, and these are baseline minimums of what the readiness level I'm expected to maintain that classification, has a 60-hour time frame, and that has a 30,000 protective boom requirement, 300 foot per skimming system, an effective daily recovery capacity of 1,050,000 gallons, and also a temporary storage capacity of 2,100,000 gallons of oil. So these are the planning standards that we are held to, and these are the planning standards that anyone transporting oil that has a facility response plan needs to maintain name resources that are on par with this kind of thing. And in this case, we're talking about Enbridge, and Enbridge names us in that plan for Line 5, as well as, I believe, one other OSRO as well. So they have some duplication in that regard. So that kind of gives us the framework of response timeframes and capacities, minimum timeframes and capacities that are being espoused right now.
If I could.
Did you say 6 days?
I said 60 hours.
60 hours.
60 hours. Yes. Sorry.
If I could, this whole issue is very relevant in the context of planning, contingency planning. This question is one that Steve and I talk about all the time in the context of these response plans that Enbridge and other pipeline companies are developing. This is an evolving, dynamic topic, and it's one that we're always looking at. It's one that we're striving to better understand and improve. And in regard to the straits, we have some questions. about whether there are enough resources available to respond in a timely way, or if there should be more. We're in the process of evaluating that, and we are intending to have discussions with Enbridge. In the case of the other pipeline company, MarkWest, we are evaluating their plans as well in terms of how quickly can they respond to different scenarios. We're evaluating the ability of the other response communities, the agencies, if you will, to respond. So all of those are factors that go into the plan. They're not done deals. We're looking at them. Anything you want to add?
All I would say is the plan is ambitious. There's a lot of area to cover in the straits. We're protecting a lot of area, so as Ralph pointed out, that would require a great deal of resources, like Bill already mentioned. And again, yeah, ideally, we'd love to see a fire truck in every driveway, and we'd love to see more resources in the area.
Yeah, and I guess just in response to that, there's been a great discussion on all the different agencies. We do maintain people within our organization. That is a changing dynamic. We're adding people all the time, and I think exercises, when we get together, do joint exercises, it is a good time to take a look at who do you bring to the table, do you need more, where do you need more, that type of thing. And so we don't just rely on our own people. We have them trained, but we also contract with the Osros. And in a major incident, we would be getting the NRC call, we'd be making phone calls, Osros would be going, we'd be going, the agencies would be going. And I think at the end of the day, there is a forming period of time. It does take time to form, but I think you start talking in terms of hours, and before you kind of start talking about days. And so I think you do end up, with a lot of equipment, boom on the ground. And that's the importance of the ICS system, to make sure that as people are rolling into town, you have some semblance of structure as you bring all these people and resources and put them to work. So anyway.
Great, thank you. Okay, I'm going to make an executive decision here. I'm going to skip the next two questions, and my goal will be to ask the following question, skip the next one, and then finish with the last for the following two, and then we'll call it a night. So 3 more questions here. This follows right in with what we were talking about. What cleanup and containment resources, including length of boom, are available on each side of the Straits of Mackinac and in Indian River? And that one's for you, Bill.
All right, well, I'm going to state what boom I know is in these areas. These are companies and entities where I have contractual arrangements and agreements in order to access that boom. So what I'm telling you is boom that I know is there. Relative to the straits, I believe there's 4,500 foot of boom on both sides of the bridge itself.
So each side has 4,500 or total?
4,500 total.
Okay, thanks.
That's, mile 55, so just under a mile.
Under 1 mile, okay.
Under 1 mile of boom is available in those two locations. And in terms of Indian River itself, there is a response trailer parked in Indian River that has 400 foot of boom on it. Now, spreading out from those areas, and I think that I should mention this part of it, 400 foot at Indian River, okay? There's 2,000 foot in Sheboygan, Michigan.
Ma'am? Okay, thanks. Just let him finish his answer, please. Thanks.
Okay. There's 10,000 foot, okay, in Rogers City, okay. There is, I believe, 3,000 foot in Kalkaska. And up in the Sioux, I believe there's 16,000 foot of boom. Now, spreading out from that range, okay, I have 10,000 foot in Detroit, I have 1,000 foot in Bay City, 1,000 foot in Marysville, 1,000 foot in Marne, 500 foot in Gary, Indiana, 1,000 foot in Toledo, 1,000 foot in Duluth. That's just marine pollution control.
What quality?
Good, very good. Inspected boom, annually inspected boom. All of that boom that I just stated. So that's the reality of my picture of boom that I know is available for these response areas. And from those mileages and so on and so forth, you can draw the conclusions of what Ralph was referring to. Okay, that It will start out, with pinpoint accuracy, and then it will cascade into a larger and larger operation. Those are my inspected, vetted locations. I know that from Missouri.
Okay, thank you. We're going to go on to we're going to skip this one and go to, has anyone generated a three-dimensional hydrodynamic flow model of the Straits of Mackinac that has been used to predict dispersion patterns from a range of oil spill scenarios? If not, why not? And we'll start with Enbridge on that one.
Yeah, so our planners do consider 3D in doing their dispersion modeling, and that factors into our tactical response plan and how we would look at plume deployment and where it moves. And we don't typically, I know the other agencies use their own dispersion models, so they'd have to speak to whether they use 3D, 2D, or what technology.
Steve, any response there?
We have trajectory models on file in our geographic response plans and our ACPs. Those are developed by NOAA, so we do have trajectory models. As pointed out, just something we don't share for security reasons, but yes, we have trajectory models on file.
Okay. Follow it? Beth?
If anyone is interested in seeing a 2D model, I do have one, or you can contact me. My email is wallaceb06@gmail.com.
And we'll supply that too in follow-up. Okay. And then, any other follow-up there? Okay. So now the final question then, why are automatic or remote shutoff valves not required to be installed at all water crossings? Is this even considered to be a best management practice? We'll start with PHMSA.
Yeah, I guess I really can't answer a question on why this hasn't been done yet, but valves are required on each side of any water crossing that's over 100 feet, on new pipelines, new hazardous liquids pipelines. There's other specific requirements, and another one that's a little bit more difficult to evaluate is if they can reduce the potential for significant pollution, or it's wording something like that. So that's more of a subjective evaluation. Those valves are required. It's not required that they be automated. So if you look at an old pipeline, there'll be valves on each side of every river crossing, but sometimes they're very difficult to get to. Now we have a rule, potentially you have a docket set up for rulemaking. We've done a study that was completed last year on the effectiveness of installing automatic shutoff valves or remote control shutoff valves. And that study's out there if you want to read it. That study's going to be used as a potential in the docket, as a potential rulemaking. From the practical perspective, new pipelines, people are looking at valves and they're installing automatic remotely controlled valves. That is the state of the industry. I can't think of any case where people are not actually remotely locating valves that I'm aware of on any kind of a new construction project. In addition to that, as part of the integrity management activities for companies to protect specific high consequence areas, they're required to evaluate